Hi, my name is Rotem. I'm a mobile infrastructure engineer at Wix. And I'm here to talk about stuff in React Native. So let's just dive in. Being a good citizen is a term often used by the Android framework team. As a developer, being dismissive of the amount of resources that are being used in the application is something that is probably not that a good idea. So let's try to make a comparison between what a good citizen means in the real world and what it means in mobile land. So in the real world, as good citizens, we want to obey laws. In the mobile land, we want to make sure we're not being malicious and that we're respecting the user's privacy. In the real world, we want to respect the natural resources. We're not going to leave the tap open, right? When we leave the sink, we don't want to leave the car engine running, and we don't want to do any kind of something that is not respectful for the resources themselves. In mobile land, we don't want to abuse CPU. We don't want to consume lots of RAM. And we want to minimize bandwidth usage. Well, it all comes down to battery life, right? And the most important thing about that is that users notice. Users know when your application abuses their phone. And with users, there are no second chances. They want the app fast, useful, and without consuming lots of resources. So I just collected a few reviews from users on pretty big applications on Facebook and Facebook Messenger, Google+, Google Chrome, and Apple Music. And as you can see, everybody makes mistakes. Even the big ones make mistakes. The last one is my favorite. By Mark Zuckerberg. Don't download that. It will ruin your phone. So we're talking about applications that are often laggy, and users are used to high performance today on native applications, and one of the most notable performance issue is sub 60 FPS animations. So let's take a step back and understand the illusion of motion. The human eye, it doesn't act like a camera. There's no snapshot. There are no snapshots sent from the eye to the brain. Instead, the brain is constantly processing visual stimulations that are coming from the eye. Frames are effectively a hack. It's a hack on our eyes, on our brain. By displaying images fast enough, we can trick the human eye and the brain to perceiving motion where there's actually isn't any. So how fast we display those images? Well, this display, it has a large effect on how fluid the motion actually looks to us. So if we take a look at this video, we can see, oh, that's nice on the right screen. Yeah, it's great. So the minimum you need in order to start perceiving motion is from 10 to 12 frames per second before the human eye actually starts understanding that we're talking about animations. It's like the flipboard we saw on the previous video. However, it doesn't look that smooth. If we're going up to 24 or 30 frames per second, that's the frame rates we usually get on TV or on cinema films. It looks a bit better, but these actually look good only because there's motion blur. But I don't want to get into it. 60 frames per second is is the sweet spot? Well, most humans won't be able to perceive the benefits of going over 60 frames per second. So I'm just want you to look at that video and see if there's any benefit of going 120 frames per second. Is there anyone can see any difference between the 60 and the 120 frames per second? Yeah, you can? Which ones? The 60 and the 120? All of them? Precisely the same? Okay. How about now? Oh, okay. How about now? What? They're not. No, they're not actually. They are actually. No, they are actually. If we'll stop them at a 15 on one. It's 1/15 of a second. Then everything will be synced. So, if you did see a difference, well, your brain is lying to you because this video is 60 frames per second, and there's no way there's a difference. What am I mumbling? Why am I mumbling about this? Any of you who developed purely native applications understand that there is a clear set of rules to making your application running smoothly at 60 frames per second. Well, the major one is offloading work from the UI thread. And when we talk about React Native, the deck of cards is being flipped. Being shuffled, I'm sorry. As this framework works very differently. Guy gave you a pretty good explanation about that. They work differently of native apps. Well, React Native abstracts the native environment, and to a certain extent, of course. But is that good for the developer? So that's by no means a complete pros and cons list, but just for my purposes. So what are the pros? The pros are, everybody talks about that. That's a true cross-platform solution, and the shared business logic, and learn once, write everywhere. You can use your JavaScript skills on both Android and iOS, and you can truly be more productive. But the cons are that the system itself, your application, is much more complex than a true native application. It means there are more moving parts. It's a big framework with a JavaScript virtual machine and a complex translation mechanism. That's what Guy talked about. And when things break, it's much harder to understand. Okay, so in order to understand the system, we need to have a knowledge of its core. And this is courtesy of Tal Kol. He used that diagram on a talk he had in the first meetup. So at the high level, I'll be repeating a bit of Guy's talk. At the high level is that there is a translation being handled by the bridge, the message queue. And most of the operations we do are being passed over the bridge. Network requests, network responses, layout measurements, render requests, user interactions, I/O operations, almost everything that includes non-arithmetic calculations, or, well, you're laughing there, I see you. And making sure that the message queue isn't congested is critical in order to ensure the smooth operation of the app. So React Native made a pretty good logger for the message queue. The message queue has a spy feature, and enabling it will emit logs and logs of all the messages that are being passed from the JavaScript to the native and back, and it will help us to understand what actually is being what actually happens in our application. So let's take an example of a simple layout. We're defining a layout using JSX, nothing too fancy. That's actually the default welcome hello world application of React Native. So the business logic in React Native is being written in JS, and the views are native. So we need to do this, this translation to native. So when we start looking at the logs, this is actually the log that is being output from the message queue when the system generates the native views. So we can see that there is a native module being called UI Manager, and there is a function that is called create view, and it tells it to create an RCT view with all kinds of parameters, and it's creating it's telling it to create the view with specific layout parameters and some text, nothing too fancy. And here, that's a different output of a single touch event. And I'm just going to go over it a bit. The first message is from the native to the JavaScript. I'm not sure you can see it. Is that okay? Can everyone read? Okay. So the native tells the JavaScript that the touch event has started, and it's sending the information of this touch event, and it also starts a timer to calculate the length of the touch event. When we use applications that have touch input in mobile applications, we usually have a touch start and a touch end. It's when we press and when we leave. So the first one is touch start. The second event is the JavaScript telling the native, well, okay, I understood that view is the touch event when it is being calculated by JavaScript on the shadow DOM. This is the actually the view, the whole hierarchy being calculated also on the JavaScript side, just in order to understand the business logic and understand which view needs to be handled now. The JavaScript tells the native, okay, I see that native view with ID 23 needs to handle this touch event. And then the native says, okay, touch event has ended. I put my finger, I left the finger of the screen, and the handler is being reset. So how these things work have actually a big impact on how the app performs under stress. The communication between JavaScript and native is asynchronous, and the queue handles the messages as they arrive. And assuming that the bridge is now, the JavaScript thread is now busy, messages that are being sent will be handled with large delays. So, frozen UI. Anyone who used the phone ever have encountered frozen UI on certain applications. You don't need to be a developer to experience this. This happens on iOS and Android applications when there are long-running operations on the UI thread. But in React Native, it's a bit different, because React Native does a pretty good job of offloading everything from the main thread, giving the main thread the freedom to only render views, and all the business logic is executed in the JavaScript thread. We'll call it MQTJS from now on, okay? And we may encounter now that this works as it does, we may encounter different kind of sluggishness in the application, and than what we've used to in native applications. And instead of being non-responsive, and on Android it may cause this screen that that is called an ANR, application not responding, the app will feedback to touches. You will see that everything, the native view itself is responsive. If there is a scroll view that is being scrolled natively, it will work as expected. But nothing else, nothing that actually being written in JavaScript, handlers, callback handlers will not work. And we're going to see a little demo of that. So for the purpose of this demonstration, I extracted example movies. It's an example from React Native. It's inside the main repo. And I made a few changes just so we would be able to get a better understanding of how it works. So let's take a point of reference. This screen recording is running on Android emulator on my computer, and a message queue spy logs being emitted, and I'm watching them via ADB on Android. So you can see me clicking on Jack Reacher. Great rating. So what happens here is that we can see, well, we can't actually see that, but if we'll stop the video, we can see that there are touch events being sent to native and back, and layout operations to the UI manager. And also the animation. The animation here is also a JavaScript animation. So the alpha values for each frame are also being sent from the JavaScript to the native side. But take this as a point of reference. This is how the app should work when it's written like this. So what happens when the JavaScript thread is under heavy load? When I'm going to press the spam MQTJS button, that's the button that is most close to the search bar, a function that is called the function act busy is going to be called. This function just calculates times from start to now, and it just goes like this for 8 seconds. This renders the JavaScript thread completely useless. Nothing can work, nothing can be handled by the JavaScript thread. The only thing it does is just acting busy. So this is how the app works when it's busy. I'm spamming the queue, I'm spamming the MQTJS, and you can see I can scroll the native view, but when I press, nothing happens. And then after 8 seconds, it works. Now, you can see now that the message queue is stuck. Nothing is being handled by the message queue. No logs are emitted on the message queue. It's just frozen. The application itself, the actual JavaScript is frozen, but the native works. Okay, where are we now? And did any of the actions we invoked got queued? Yeah, if you can see, going back. So if you can see here, I'm spamming the queue, then I'm trying to press it. You see that? Well, I stopped now. I'm just waiting for it. And then it works. I mean, everything, the messages are being queued, but nothing is being handled, actually. Nothing, it can't call the JavaScript callback. So it just handled the Jack feature app? It didn't handle it, it just, oh, so did it just handle the Jack Reacher tab? Yeah. It didn't, the native just created a message that is now being sent over the queue, but it stops because JavaScript can handle that now. Oh. The last press was handled, not the previous one. Actually, we had this kind of shenanigans in our app before, and it was handled multiple times by the JavaScript. So yeah, it could be. Yeah, it could crash the app or open multiple screens. Yeah, it does. It's a twilight zone there. Yeah, it's funky. Anyone here? Okay, great. So let's go to the second. So what happens when there is heavy load on the message queue itself? The heavy load on the message queue also can cause delays on callbacks and choppy JavaScript animations, and it actually I can just show you. Spamming the bridge here. Actually, now just creating, I'm going back again. I'm setting a timeout and calling this set timeout thousands of times in a second. Set timeout in React Native is being translated to timing create timer in native. And create timer in native actually returns a callback to JavaScript when time passes and the timer is done. So what happens here is thousands of messages going from JavaScript to native and coming back and spamming the queue. And running the app now actually seems like it's working pretty okay, but we really can't actually see the important messages we want to see, the on presses and the handling of their creation of the views. We can just see all the crap from create timer. And the app itself, look at the animations. They are not as smooth as they were before. And just a reminder, this is working on an emulator powered by a Core i7 on my computer. It won't work like this on a device. Okay, so going forward, let's see how these situations affect the CPU. So first, let's talk a bit about basic CPU usage terms on Linux, because Android. U time is CPU time spent on user code. It's measured in clock ticks of the CPU. And S time is CPU time spent on kernel code, which also is measured in clock ticks. In Android Studio, we can open an Android device monitor, which is this lovely screen here. And we have a few very great tools that can help us understand what's going inside any application. So we want to click the button in the red rectangle here. This is update threads. This is just Android. I'm sorry, guys. Yeah, bye. Okay, so we can see MQTJS here. That thread has spent 22 CPU ticks on the first demo I showed you, on the point of reference. So 22 ticks, right? The next one, are we in the next one? We are. Okay, the next one has spent almost 1,600 on S time and 25 on U time. This means that we can see that MQTGS now works very hard on doing stuff, and the JavaScript thread was actually being spammed and worked very hard. And when we take a look on the third one, which is that the message queue is being spammed, we see something different. The MQTJS is also being spammed, right? We have here 700 and never mind. You know, it's above 2,500 CPU ticks on MQTJS. And another thread is joining the party here. That is MQT native modules. On Android, there is a thread that handles all the logic that is being executed on native modules. And this thread is also being bombarded here. And let's try to understand why. Well, first, the JavaScript thread is very busy on creating messages and passing them over the bridge just to create timers. And then the native module, in turn, is creating those timers and waiting for them to end and sending back callbacks. It also creates messages and sending them over the bridge. So both threads are very, very busy. So the main takeout here is that excessive traffic over the bridge puts both the JavaScript and native threads in overdrive. So problems. Yeah. The Android UI thread is not busy. That's right.
The UI is responsive.
The native handling, the UI thread is not busy. Yes, it is not busy, and the native handling on the UI thread is working as expected. So if you would make a sample application that has a native on-click handler on one button, and the other button is handled in JavaScript, the native button will work perfectly, and the JavaScript button will just have to wait for the message to be processed. So going back, as we said before, we have to respect the message queue. We have to know what's going on the message queue, and when we have bugs, we have to understand that that's the first thing that we need to log in order to understand how the application works. And actually, that's a pretty good point of reference to anything that a pure React Native application does, because I don't know any kind of tool that can show me all the events that are being handled on the native application from and for free, right? Calling network requests and I/O operations and native handling of touch events. Everything's being streamlined in the log of the message queue. There's nothing that I know of that works like this for free out of the box on the native platforms themselves. So it's a pretty amazing tool. So problems. How do we solve them? Well, there isn't any definitive answer for that, and you have to know what your code does. So debug your code, use the message queue spy logs, monitor the CPU. You can also use remote debugging and use a Chrome profiler to see what is actually being invoked in the JavaScript thread, and find the smelly parts and fix them. Eitan Sharabi, TM. So you can try it for yourself if you want. It's in my private GitHub. It's a private it's a public GitHub repo in my account. And there is also a Medium post I wrote about this. You can go inside and find more details about what we just spoke about. And I think I'm done. So if you have any questions. So that's a hard question. Yeah, I'm going to repeat it, the gist of it. So the smart guy here asked if Android and also iOS, the rule is flatten your views. Make them as performant as you can. The less views you have in the hierarchy, the less time it will take the UI manager to traverse over the tree and create the views for you and update them. So React Native, well, the UI manager, that's the class that actually creates the views, gets the events from JavaScript from the translation of the JSX back to native. It's well, I'm not sure it's on par with native applications. I know that there is some bloat over there, and I'm sure that is something that Facebook are looking into very hard. But I don't have an answer for that. I hope it's okay. I don't know. If there is nothing else, then thank you very much, guys.